You know, the whole AI race right now feels like it's all about who can build the biggest, most expensive model. But what if that's the wrong way to think about it? A new protocol is flipping the script and asking, what if we could build AI like Lego? Instead of these giant one-size-fits-all brains, imagine a world filled with small, specialized, interlocking pieces that just snap together. It's a pretty radical idea, so let's get into it.
So this really lays out the two different worlds. On the left, that's where we are today, monolithic AI. It's one giant, super costly brain trying to be an expert in absolutely everything, from writing poetry to debugging code. But on the right, that's this new idea, composable AI. It's more like a swarm of specialists, these small, super efficient experts that team up to tackle problems. And this isn't just some small technical change, it's a direct answer to how expensive and inflexible AI development has become.
All right, so how do you actually take apart that giant brain? Well, it all kicks off with something called the brick revolution. And that's the core concept here, breaking down these huge AI models into much smaller, more manageable, independent pieces. And this is the star of the show, the brick. So what is it? A brick is basically a self-contained, specialized AI skill. It's not a whole AI model on its own, nope. Think of it as a small module that you can just add to a base model to give it a brand new ability. It's exactly like snapping a specific Lego piece onto your castle to add a new window or a turret. Now, what's really cool is that not all bricks are created equal. They come in three main flavors. First up, you've got adapters. These are kind of like putting on a pair of glasses. They help a general AI model see a very specific task way more clearly. Then you have experts, and these guys are hyper-specialized. I mean, one expert might be a genius at translating German legal contracts into English, but that's pretty much all it does. And finally, you have gates. These are the traffic cops of the system. They look at a request and go, okay, for this job, we need that expert.
Okay, so you've got all these amazing specialized bricks. That's great, but there could be millions of them out there. So how on earth does the system find the perfect one for your task and then put them all together on the fly? Well, this is where the real magic happens.
The whole system hinges on this idea called semantic routing. It's powered by something with a fancy name, the hierarchical expertise address space. But honestly, the best way to picture it is like a Dewey Decimal System, but for AI skills. It's this incredibly smart universal catalog that lets the network know exactly where to find the perfect brick for any task you can dream up. And we're not talking about a simple keyword search here. Oh no, this is a really sophisticated four-step process. First, it analyzes your request to figure out what you really need. Then, it prunes down the gigantic search space to just the relevant categories. After that, it ranks all the potential bricks based on stuff like their performance and how trustworthy they are. And only then does it make the final selection. This is how it can sift through millions of options without breaking a sweat.
Now, the hunt for the right brick happens in three different layers, starting with the fastest one. Layer 1 is your local cache. Just think of it as the toolbox you have sitting right there on your own computer. It's an instant lookup of all the bricks you've ever used before, super fast.
But what if the brick isn't in your local toolkit? Well, the system just widens the search to Layer 2, the peer network. It uses a distributed system to basically ask its trusted neighbors, hey, anyone got a brick that can do this? It's a totally decentralized way to find skills from other people on the network.
And finally, if it still can't find the brick, the system goes to the last resort, Layer 3, the global registry. This is a permanent, blockchain-based record of every single brick available. It is the ultimate source of truth, making sure that if a skill exists anywhere in the world, you can find it.
So, finding bricks is one thing, but how do you know you can actually trust them? This is so important. And that brings us to the economic and reputational layers that are baked right into the protocol to make sure quality is high and good contributors get rewarded.
Every single brick has what's called a trust vector. And this is not just a simple 5-star rating. No, it's a multi-dimensional score that looks at everything. Its performance history, how reliable its uptime is, what other users are saying about it, and this is key, whether its creator has put up an economic stake to vouch for its quality. That trust system is awesome for spotting the good bricks, but how does the network actually encourage people to be good and, maybe punish the bad actors? Well, that's where the system's own internal economy comes into play. The whole economy runs on a single native token, and it's called util. And I want to be clear, this is not just some speculative asset. It's a true utility token with very specific jobs that make this entire network run smoothly and, most importantly, securely.
And this slide just lays out its three key roles perfectly.
First, you use UTRL to pay for using the bricks. That's the inference cost. Second, creators stake UTRL as a form of collateral to build up a good reputation for their bricks. And third, and this is the enforcement part, that stake can be slashed or taken away if a brick misbehaves. It creates this really powerful economic reason to be a good citizen on the network.
One of the most ambitious things about this protocol is just how it's designed to scale. This isn't just for huge corporate data centers. It's built to work at literally any level, from a single computer in your house to a massive global network.
Just look at the range on this. It can run in a local setup on just a few GPUs, scale up to a whole cluster of servers, expand even further to a federated network of different organizations, and ultimately, it can operate as a global swarm with over 10,000 nodes. That kind of flexibility is absolutely central to the whole vision.
Okay, so let's zoom all the way out for a second and look at the big picture. What is the end game here? What does a future built on this idea of composable AI actually look like? This quote from the source material just nails it. The aim is to create a global marketplace of modular AI capabilities. It's about getting away from these proprietary, closed systems and moving towards an open market where literally anyone can create, share, and use specialized AI skills. And this right here, this is the fundamental shift. We go from the left side, these isolated AI giants living inside their own walled gardens, over to the right, a dynamic, open ecosystem where all these cooperating specialists can combine their skills in totally new ways to solve real problems.
Which really just leaves us with this final thought to chew on. Imagine a world where the next big innovation isn't limited by who has the biggest supercomputer, but by who has the most clever idea for a new brick. Seriously, what kinds of problems could we solve if any AI skill we could possibly imagine was just a single brick away?